A squared plus B squared equals C squared. That's the Pythagorean theorem. Let's learn about it. The Pythagorean theorem is where we can figure out any missing side to a right triangle. We have three side names. We have side A, side B, and side C. A and B are both legs of a right triangle, and C is the hypotenuse. Okay? And so the legs don't really matter. This one we could call A, this one we could call B, or vice versa. We could call them the opposite way around. I can call this one B and this one A. Doesn't matter. But see how this here is the right angle? Across from the right angle is always going to be your hypotenuse, C. Okay? C is always going to be across from the right angle. That's one clue that it's the hypotenuse. Another clue is it's always going to be the longest one of those lines that create that triangle. So to make a right triangle, you need to have two legs and a hypotenuse. To solve for any missing side, we're going to use the A squared plus B squared equals C squared. So I'm going to name my sides A, B, and C, and I'm always naming the hypotenuse C. So let's call that one C, and then I kind of like to order mine in order from least to greatest. So I'm going to call 6A and 7B, and I'm going to write this out. A squared, which would be 6 squared, plus B squared, which will be 7 squared, equals C squared. We don't know what C is yet. So what I'm going to do is I'm going to take on my calculator, I'm just going to type in 6 squared plus 7 squared. And I get 85. That's the same as C squared, but I want to know what's the same as C. So in order to unsquare a number, I have to take the square root of that number. Whatever I do to one side, I have to do to the other side. So I'm going to now take on my calculator the square root of 85. And I got this long number. You can round to the nearest tenth. So I got 9.219544, blah, 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 right? I'm going to round it to 9.2. And I'll just call that units since it doesn't have a measurement given there. And that's how long side C is. If I'm looking for a side that's not C, I'm going to use that same Pythagorean theorem, but I'm going to use it in a little bit different way. So again, we've got A, B, and C. Which side is C? It's this one. Which one's A? Which one's B? It doesn't really matter as long as it's not the longest side. So we'll go like that. If A squared is 10 squared and B squared is just that X, I'm going to call it B squared equals C squared, which is going to be 20 squared. Notice I'm going to have to solve for B. So there's two ways of doing this. I'm going to go ahead and use the solving method first. So I'm going to take 10 squared, which is 100, plus B squared equals 20 squared, which is 400. I'm going to subtract 100 from each side. And now I have B squared is equal to 300. And I want to know what's the square root of that because that will give me B alone. And so on my calculator, I'm just taking the square root of 300, which is about 17.3. For all of these, you should make sure that the number makes sense. So yep, that makes sense that would be 17. If I forgot to take the square root, it won't make sense. For example, that would have been 300. 300 wouldn't make any sense to be on this side of the triangle when the longer side is 20. So try and make sure that you're using common sense when you're solving these. The other method is a little bit faster. It's where you take your C and you subtract the piece that you already know. So I could take my C squared minus my B squared to get, A squared to get my B squared. So basically all I did was the same thing I did down here, only I started with subtracting. So see how I subtracted this off? I'm subtracting the same problem, 20 squared minus 10 squared, but I can write that in my calculator as 20 squared minus 10 squared, and I get 300 again, and I can take the square root of that. So that's the first type of problem that's going to be on your test. You're going to have 4 problems where you're trying to find either A, B, or C. The next type of problem is going to be asking you is this possibly a right triangle? And in order to know if it's a right triangle, we're going to use that converse of the Pythagorean theorem, where instead of saying if a squared plus b squared equals c squared, then it's a right triangle. Sorry, I should say, I think I said it backwards already. So all right triangles would have a squared plus b squared equals c squared. Therefore, here's the converse. If a squared plus b squared equals c squared, then it's a right triangle. So basically all I'm saying is if you can plug in the numbers for this formula and it works, it's a true statement, then it's a right triangle. If it doesn't work, then it's not a right triangle. So what I'm going to do here, let me get a different color, is I'm going to plug in the three numbers that I see. I've got a 15, a 30, and a 45. It's very important that the longest one be your C. So I'm going to plug these in. 15 squared plus 30 squared equals 45 squared. And I'm going to test this. I'm going to take on my calculator 15 squared plus 30 squared, and I get 1,125. Then I'm going to take on my calculator again, 45 squared, and I get 2,025. Because 1,125 is not equal to 2,225, this is not a right triangle, and so the answer is no. So two things, is this a right triangle? My answer is no. Second thing is my proof. Justify your answer. Justify your answer just means showing you putting it in a squared plus b squared equals c squared order, and then showing does it equal it or not. Okay, let's do another one. So over here, 12, 24, and 36. 36 is my C because it's my longest. So I'm going to take 12 squared plus 24 squared equals 36 squared. And I'm going to test it. 12 squared plus 24 squared equals 720. And 36 squared equals 1,296. Since those are not equal, we'll say nope. And this is my justification right above, just showing me plugging those numbers in. The third section on your test is going to be where you're trying to find the distance from one thing to another on the coordinate plane. So for example, I'm going to find the distance from the circle to the heart. So I'm going from the circle to the heart. That's a little bit of a crooked line, but I'm going that distance. Notice I can't just count those boxes because I'm not getting full boxes. It's not a straight count. So instead, I'm going to do what I think of as like the long route. I'm going to go across here and up. And notice how I just created a right triangle. So I'm going to use one of these as A, one of these as B, and this one that I created, the long one, is going to be my C. So I'm going to plug this into the Pythagorean theorem. I've got 3 squared plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squared equals C squared. So I'm going to solve for that. In my calculator, 3 squared plus 11 squared equals 130. And that equals C squared. So I want to take the square root of each. The square root of 130 is about 11.4. So this is 11.4. Let's try the next one. The next one asks us to go from the square to the circle. So that is going, let me get a different color. That's going from here to here, okay? Again, that's my diagonal line. That's going to be my C. You'll notice it's my C as soon as I draw this other part because I'm going to create a right triangle out of what's here. So if I count 1, 2, 3, 4, 5, that can be A or B, and 1, 2, 3, 4, 5, 6, 7. That can be my other one, my other leg. So I've got 5 squared plus 7 squared equals C squared. 5 squared plus 7 squared equals 74. I'm going to take the square root of 74, and I get about 8.6. Okay, the last section. The last section is where we're trying to find we're trying to problem solve. And so when I'm trying to problem solve on here, I'm going to have a variety of questions. And this one's asking directions. I'm just going to read it. To get from his house to the store, Mr. Hale typically walks 20 yards east. So going east, 20 yards on Oak Lane, and 12 yards south, 12 south on Main Street. Okay. How much shorter would Route X be? This is a tricky question. There's one just like this on the test. It's not asking me what is X. If you read this too quickly, you're going to just find out what X is and move on. And that's only going to give you a half a point on the test. You need to actually answer the question, how much shorter would Route X be? So the first route is 32 because we're taking our 20 and our 12 together. It's 32 yards. We know that it will be quicker for us to travel this route or shorter, but how much shorter? Well, let's find out what it is. This is our hypotenuse. We're going to take 12 squared plus 20 squared to get our x squared or our c squared. So if I take 12 squared plus 20 squared, I get 544. That equals c squared. I'm going to take the square root of both. So the square root of 544 is about 23.3. Okay, so if this is 23.3 and this other way is 32, I want to know how much shorter it is. Well, I'm going to take 32 minus 23.3. I'm just going to do the math the long way here. Okay, it's 8.7 yards shorter. So just be really careful that you're thoroughly reading the directions on those. If there isn't a picture, make sure to draw a picture first so that you can kind of understand where each number belongs. And remember that the whole point is that you're going to be solving a Pythagorean theorem question. So make sure that there's something that you're doing in that kind of math. Best of luck. Have a good night.